This is our last video looking at combining two functions using basic arithmetic to obtain a new function. Here we want to take two functions and divide them. So I have two functions f and g. Let's go ahead and compute f divided by g of 4. As with the other arithmetic combinations, we do what is very natural. We just take our function f, evaluated at 4, and divide it by our function g, evaluated at 4. F of 4 is the square root of 3. G of 4 is a -1. So f divided by g of 4 is equal to negative square root of 3. Haven't seen that basic idea, let's go ahead and find the general formula for f divided by g of x. By definition, we're going to take the formula for f and divide it by the formula for g. In this case, square root of x minus 1 divided by x minus 5. At this point, we would cancel common factors if we could. That option is not available here, so this is the simplified formula for f divided by g of x. The next thing we want to think about is the domain of this function. If x is in the domain of f and the domain of g, then I'll be dividing a real number by another real number, and I will get a real number out as long as g of x is not 0, right? We cannot divide by 0. So that is how we find the domain for f divided by g of x. We are going to take the intersection of the domains of f and g, as in the previous videos, but we are going to throw out any x value that makes g of x equal to 0. So, start by finding the domain of f. F is the square root of x minus 1. We have to make sure that x minus 1 is greater than or equal to 0. So the domain of f is any x that's at least 1. And there's the graph for that set. Then consider the domain of g. G is a polynomial, so the domain is all real numbers. Then we want to consider the x's in common to both of these sets, right? Because if x is common to the domain of f and the domain of g, we'll be dividing a real number by a real number. The intersection of these two sets, or the x's in common to both of these graphs, clearly starts at 1 and includes any x greater than 1. From here, we need to throw out any x value from this graph that makes g of x equal to 0. So we're going to set g of x equal to 0. We find that x equal to 5 makes g of x equal to 0. We need to take that out. So I'm going to put a hole at 5 and leave the rest of the graph intact. So this is the graph for the domain of f divided by g of x. Bracket 1 up to 5, union 5 to infinity. Bracket around the 1 because it's included in the domain, parentheses around the 5 because it is not included.